Hello, everyone. I will be talking about hot bee balls and the relationship between Japanese honeybees and Asian giant hornets. I will talk about the process of hot bee balls and that formation, as well as the cons, the consequences for that. And yeah, all right. So, Apis cerana japonica they're commonly referred to as the Japanese honeybee. They've developed a unique defensive mechanism against their biggest predators. The scientific name as the Vespa mandarinia, or commonly referred to as the Asian giant hornet. So these hornets are actually very invasive, and they love to send out scouts from their hives to seek out potential beehives. And this poses an immense risk to honeybees in both the eastern and the western hemisphere, because when these hornets discover potential honeybee hives, they like to attach markings to attract their nestmates toward the nest of honeybees. And so once this happens, honeybees of that particular hive, they have to act quickly because two things can happen after this point. The hornets could leave to alert its colony about the newly discovered hive so that they can group up and take over the hive itself and its resources, or the hornet that found the hive could immediately start killing the honeybees inside the hive. And so this is already a major issue in the United States with Apis mellifera, commonly referred to as European honeybees, because they don't have the evolutionary ability to create effective hot bee balls. So they resort to stinging the hornets, but their venomous stingers are too small to actually pierce the thick exoskeletons of those hornets. So really they're kind of pointless. Japanese honeybee workers can create hot defensive bee balls by first getting themselves prepared to engage in the bee ball activity by first warming their flight muscles. And so once the hornet has entered the beehive and has made itself comfortable, the bees can choose to immediately attack the hornet or wait until it attacks first, then retaliate. Um, One very interesting fact that I actually learned about Japanese honeybees is that they're actually very calm. So they tend not to attack first as often, and they do keep to themselves as to not disturb other beings around them. And so I feel like this is really truly ironic as to how such a peaceful race of honeybees evolved to possess such a dangerous natural ability to fry their enemies. The lethal limit of Japanese honeybees is around 50 degrees Celsius or 122 degrees Fahrenheit. Whereas for the Asian giant hornet, it's around 45 degrees Celsius or 113 degrees Fahrenheit. One study actually found that bee ball participants died significantly shorter than non-participants of identical age. There was a suggested reason for this shortened life expectancy of those Japanese worker honeybees. The worker bees that were in the center of the bee ball are in more danger because the Asian giant hornet can defend itself from the center working bees. Also, by being in the center of the bee balls, those honeybees are exposed to higher temperatures as well. Potentially, bee ball formation could be detrimental for the entire Japanese honeybee colony itself. Within honeybee colonies, workers play a critical role in determining the needs of the colony. They can tell what resources such as carbs, protein, water, and propolis need to be foraged. Workers are the ones who go out and gather nectar and other resources for their colonies as well. If too many workers are dying, then this can cause other issues to arise as well as within their colonies, and ultimately the colony would fail because there isn't enough preparation for the winter season. And thank you. I hope you all learned something about b-ball formation and just a little bit of background between the relationship between Asian giant hornets and Japanese honeybees. Thank you so much.